So for our last function, we can see that we've got an even highest exponent. So via our leading coefficient test, we know that that is going to be a touchdown graph. And with a positive leading coefficient of 1, that means the graph is going to be going up on both sides. And normally we would expect that we would end up with kind of something along these lines where we've got kind of a couple of bumps in there. But as we move to the graph, we can see that that is not the case. We're kind of getting a parabola type shape, but that's kind of a lopsided parabola. And so we've only got two zeros, two real zeros that we're observing, one at -2 and then one over here at 1. And then we kind of have this dented parabola shape. Here we have the y-intercept, here we have the bottom. We'll estimate that it's approximately -1, and then -10 is kind of the bottommost point of this graph. Again, we can get the exact value by clicking on it in Desmos. But the point here is, clearly we only have 2 out of the 4, since we have the highest exponent of 4, zeros that are shown there. So that's an indication that we're going to have some imaginary zeros that we have to find. So if we again go back and sketch it, we got -2 is one of our zeros, 1 is the other. Our y-intercept is always this last number here, so that's -8. Now we bottomed out, if we take a look here, at -10, so there's really not much reason for us to have to adjust our graph from going from -10 to 10 in both directions. Try that again. We'll make that look like a 10. So we bottom out here at -110, roughly speaking. So for our graph, again, we have a zoomed in version of it on the other slide there, but it's roughly going to look like this. Again, we're just looking for a general sketch. So we've got to use synthetic division for both of these zeros. Remember, this one was x equals -2. This one was for x equals 1. So we're going to use synthetic division for both of those to knock it down from being a 4th degree polynomial down to a 3rd, down to a 2nd degree, which then will allow us to find those imaginary zeros that we know exist. So we'll start off with -2. So I've got my coefficients are 1, 1, 2, 4, and -8. And so we roll through our synthetic division, bring down the 1, times -2 is -2, add and we get -1, multiply -2 times -1, we get 2, multiply or add and we get 4, multiply by -2 and we get -8, add in the vertical direction to get -4, multiply -2 times -4 to get +8, and when we add those we indeed get 0, as we should. So we're down to x cubed, or whoops, we've gone from x to the 4th down to x cubed, try that again, down to x cubed, but now we need to knock it down to x squared. So that's where we're going to divide by the other 0. So we've got 1, and now we bring down the 1 to get us started. 1 times 1 is 1, -1 plus 1 is 0, 1 times 0 is 0, 4 plus 0 is 4, 1 times 4 is 4, -4 plus 4, again a remainder of 0. And so we've gotten to the point where now we've knocked it down to x squared. Got that one right this time. And so we can write our quadratic equation that we're going to have to solve. X squared, no x term, plus 4 equals 0. So I'm going to solve by subtracting 4 from both sides. So I'll scroll down a little bit to give us a little room. So that leaves us with x squared equals -4. So hopefully we can see where this is headed. I'm going to take the square root of both sides. And so that leaves me with x equals, I of course need the plus or minus, and then I'm going to separate the root 4 and the root -1 as we have before. Root -1 gets replaced with I, root 4 is 2, so we get plus or minus 2i are the remaining 2 zeros. So all the zeros taken together are x equals -2 and 1. Those are the 2 zeros that we got from our graph. And then we that look like a 2. And then we've got the 2 that we got down here, plus or minus 2i. And so that gives us the 4 zeros which we expect from a 4th degree polynomial.